Hello. We're doing it. 56-57. Let's find out if you got them right. 56 and 57 were E and B. E is in Edgar or elephant. B is in boy. Let's take a look if you got these wrong. I like both questions lumped together because both are asking the student, do you actually know what just happened when you do a test of some sort or when you take an average? Do you know what that means? So let's read this question. It says 10 students were randomly selected from a high school to take part in a program for reading. Each student took a test before and after. So this is a matched pair. The mean difference of the score after the program and before was calculated to be 16. So difference means subtract. So right now on my paper, I'm going to write that out. Mu D is mu after minus mu before. So to calculate the difference, the average difference, I take after minus before, and they said their sample, so something like that. So the average in my sample, the average difference was the average before minus the average, the after minus before ended up being 16. So you have some amount of evidence here. We don't know how much, but we have some amount of evidence that the score after went up because the difference was positive. It was decided that, so they found that doing the program actually improved scores. So it should make sense that they now decided, it was decided all students in the school would take part in the program next year. Defining mu A as the mean score after, mu B as the mean score before. The 95 percentile confidence interval is estimating the true mean difference. True mean difference. So that's this symbol right here. So I could use a confidence interval to estimate the true mean difference for all students using a sample, and they did. They got a sample of, so the confidence interval, that was a 95% confidence interval, was 9,23. So doing a little quick math, if you subtract the 2 and divide it in half, that looks like they got 14 plus or minus 5. No. 23 minus 9 is 14. Divide by 2 is 7. So I got the number 14 from my choices. So I went a little too fast. So when I subtract the confidence interval, 23 minus 9, I get 14. And when I divide that in half, I get 7. So 9 plus 7 is 16. 16 minus 7 is 9. 16 plus 7 is 23. So the outcome was 16, interval of 9, 23 is the same thing as getting 16 plus or minus 7. So I already sniffed out why that 14 thing doesn't make sense. What they were trying to get you on B to think about was what did the center end up being? Well, the center ended up being 16, and that's what happened before. But you are doing a confidence interval, which means you're casting a net, and you know somewhere in your net is the true difference. And really what you're looking for is whether or not there's a 0 in there. And so we were excited to see there was no 0, because if there was a 0, then really that's evidence that shows that the program didn't really improve scores. So let's interpret what it does mean. So it gives us some amount of evidence that the average after is bigger than before. Average after is bigger than the before. But that's not what it's saying. It's not saying that it's the probability of that. No. We do a confidence interval, and what we're saying is that the difference, whatever we calculated, if we do lots of samples, the true difference, the true mean difference, falls somewhere in between this range 95% of the time. So that's not really what we're saying. We're definitely not saying B. that the score afterward is less, because we actually have lots of evidence here that it is effective. The third one says mu A is around 23, mu B is around 9. That's totally not what a confidence interval is saying. Not even at all. The confidence interval is saying what the difference is. So the difference between these two we calculated once was 16. If we did more samples, we think it will fall somewhere between. The difference will fall around 16 plus or minus 7, which would give us this interval. So that's basically what the last question is telling us, that for any mu A and B, that the interval, the difference, would fall between 9 and 23, and that'd be very, very likely because we did a 95% confidence interval. Next question. Gina's doctor told her her Z-score for her blood pressure compared to other women was 1.5. So 1.5 or 1.50 is her Z-score. And so all that is, that's like me saying, my height Z-score is 0. That means I'm the mean. If somebody walked in, I'd be like, wow, your Z-score is 3. That person would be 7 foot tall. So the number 3 is not their height. The number 3 is the number of standard deviations above the mean that their height would be. So the number 3 has nothing to do with inches, but if it's a positive 3, it means that's how many standard deviations above the mean I am, or if it was a negative 3. If somebody came in and was a full-grown adult, about 4.5 feet tall, that would be a negative 3. So that would be an extremely unlikely height, much, much shorter than the average height of a person. So when I think about averages, I can't help myself. I gotta draw that. And what goes in the middle? I don't know. They didn't tell Gina what her average heart rate was. But you know what? They don't really have to. They really just need to tell her relative to everyone else. So if I look at my graph, similar to a couple questions ago, I can make a normal chart. And that's 1 standard deviation from the mean, 2 standard deviations from the mean, 3 standard deviations from the mean. When I go to the right, that's +1, +2, and +3 standard deviations from the mean. So it looks something like that. And then when I go the other way, that'd be -1 standard deviation, -2 standard deviations, and -3 standard deviations from the mean. What is it that they told Gina? So if I was talking to Gina, I would say, Gina, if high blood pressure is bad, then it appears as if yours may be bad, because Gina's blood pressure falls somewhere here, which means they're telling her it is indeed above normal. So that's where 1.5 standard deviations above the mean go. And if you're trying to be average blood pressure or less, we always want to be lower than average if lower is good. You know, we don't want high blood pressure. So that looks a lot like what B is saying. B says Gina's blood pressure is 1.5 standard deviations above the average blood pressure of women her age. Thanks for joining.